Watch what happens when a system relies entirely on manual human coordination to scale. The data load becomes too heavy, and the operation gridlocks. This network model shows the root of the problem. We built platforms tied to seat licenses, which forces organizations to endure SaaS sprawl. With that sprawl comes an integration tax, the massive coordination costs required to manually connect all these separate tools. To bypass this bottleneck, we have to drop the human-in-the-loop requirement. Service as a software, or SaaSware, hands execution over to autonomous, multi-agent swarms that complete software tasks continuously and asynchronously. Today, we are going to build a 4-step transition blueprint. By the end of this exercise, you will know exactly how to convert one of your existing manual workflows into a SaaSware architecture. If your company is going to process the data loads required for the next decade of growth, you cannot rely on human operational bottlenecks. You need verifiable, autonomous execution. Let's begin the blueprint. Step 1 is architectural. Take your current workflow and draw a horizontal line straight through the middle of it. We are decoupling the user interface from the actual execution of the tasks. The top half becomes your control plane. This is a purely deterministic environment. Humans no longer push buttons to execute manual work here. Instead, you use this interface solely as a lens for observability and to set strategic governance policies. Below that line sits the execution plane. Here, autonomous agents perform probabilistic execution. They constantly process data and event streams in the background without waiting for human prompts. Map your overarching business constraints, your rules, budgets, and compliance limits to the top layer. Then assign the heavy, asynchronous data processing tasks to the agents in the bottom layer. Separating these functions ensures humans maintain strict strategic oversight. Your team controls the parameters, and the agents execute the high-volume work. Moving to step 2, we have to reconstruct your data storage. When you have hundreds of autonomous agents attempting to write data simultaneously, a traditional mutable database will fail. It creates race conditions that corrupt your system state. Cross out your traditional databases on the blueprint. Replace them with an immutable event log, where your system state is derived directly from a reliable, append-only history of actions. To make this work, you must adopt conflict-free replicated data types, or CRDTs. This network visualization demonstrates how CRDTs allow multiple concurrent agent events to merge perfectly without data collisions. Notice the secure locks mapped across these distributed nodes. CRDTs achieve eventual consistency across the network without requiring centralized locking mechanisms, meaning your system will not gridlock, even during network partitions. If you attempt to scale autonomous agents without adopting CRDTs and event sourcing, your data will inevitably corrupt, leaving you with a system state you cannot audit or trust. Step 3 addresses risk. AI models operate on probability, which means they occasionally guess wrong. To deploy them safely, we have to build rigid, quantitative boundaries. In SaaSware, agents do not execute actions blindly. They generate action proposals. Every single attempt to execute a task comes paired with a calibrated confidence score assessing its own accuracy. Next, configure a numerical confidence gate in your control plane. In this UI mockup, the agent's proposal scored an 88, but the system halts the state transition because the minimum threshold is set to 90. When an action fails to meet that threshold, it triggers an automatic escalation protocol. The task is instantly routed into a queue for a human operator to review and resolve. This establishes the policy precedence principle. Under this architecture, human-defined deterministic logic will always override an AI's probabilistic output. By implementing strict confidence gating, you effectively place a harness on probabilistic execution. This keeps your autonomous operations enterprise-grade and legally bounded. Step 4 is updating your economic model. Go back to your blueprint and eliminate any mention of software seat licenses. Autonomous background services simply do not consume human UI access. We replace that old structure with a new metric, execution yield. This line chart calculates the raw value your autonomous actions generate, measured against your standard human baseline. But gross yield is not the final number. Running continuous agent simulations requires significant processing power, so we must subtract our compute costs from that top-line value. Finally, we deduct risk-adjusted liability costs. This structure provides your organization with a clear, highly auditable roadmap to safely achieve Level 3 autonomous emergence. What makes this bridge so crucial is that SaaS aligns technical execution with legal enforceability. Because every decision is logged and verified, your operational trust becomes mathematically provable. Take this 4-step blueprint to your engineering leads. Use it to establish the baseline requirements for your own verifiable execution layer. We are looking at a structural shift in how software operates. SaaS provides the required architectural foundation for the autonomous enterprise.